We're here at KubeCon this week, and lots of people are talking about WebAssembly. There's a lot of WebAssembly companies, a lot of WebAssembly chat. People are saying it's the next big thing. But is it? I'm not quite sure. Welcome to On-Premise IT, the podcast where we go on-premise or on-topic with a specific discussion point. And yes, that's right, we're actually on-premises here in Chicago for KubeCon this week. I'm your host, Stephen Foskett, and let's meet who's on the panel today.
Hi, I'm Justin Warren. I'm the Principal Analyst and Founder at Pivot9.
Hi, I'm Ned Bellavance. I'm the founder of Ned LLC.
Hello, I'm Nigel Poulton, and I write books and I make video training courses.
So, Nigel, this was your suggestion. Tell us a little bit first to start off with. What is WebAssembly?
The future.
Okay, we're done.
All right, well done, everybody.
Except it's almost here right now. And I think my biggest challenge with it, right, so I do believe it's the future, or it has a very strong chance of being the future. Like, we talk a lot about 3 waves of cloud computing. Virtual machines, containers, now potentially WebAssembly. Each iteration being, generally speaking, smaller, faster, more secure, more portable than the previous. So you could say that WebAssembly will be to containers what containers was or did to virtual machines. Sort of eat away at them and become the new go-to. I think it's going to happen, but it hasn't quite. I mean, it takes ages for technology to hit, don't get me wrong, but it still, for me, hasn't quite got off the ground. And I know at the beginning of this year and the end of last year, everyone was saying 2023 is going to be the big year for WebAssembly development of standards. We're going to start seeing it and stuff like that. And where are we now? November? And we're not quite there, but inside me, I still believe.
Yeah.
And I don't know if I'm becoming one of those that, you know, just believes in something because they want to, and I've laid a stake in the ground, and because I've laid that stake, it's got to be the next new thing. Or is it a little bit like it was with containers? Because in the early days of containers, a lot of people were saying, no, it's never going to be a thing. It's not going to replace virtual machines. It'll only ever be for net new, greenfield stateless. And fast forward to today, and those of us who, stood by our opinions, it's borne out for us now. I don't know where it is with WebAssembly. Are we going to get there, or am I going to look embarrassed?
I saw that containers solved a clear problem that people had, which was I need a consistent environment for my code to run in.
Yeah.
And it ran on my laptop. Well, we're going to ship your laptop. How do we do that? We ship it in a container, essentially. So containers solved a real problem that developers and infrastructure and ops had, which was how do I get the code that you're compiling and is good into the production environment where it can run? So I see the clear need for containers. It may not have been so obvious 10 years ago. 10 years ago? We'll go with that.
Yeah.
But it's very obvious now, with the benefit of hindsight. What I don't see is the clear and present need for a replacement for containers. I don't see a clear and present need for the next thing. And maybe I'm just like...
Oh, I do.
Well, all right, Justin, what is the thing?
Containers is... So WebAssembly is Java, but good this time.
I feel like I've heard that a few times before. Like, no, this time
for sure.
You'll write it once and it'll run anywhere.
Well, that's the promise of WebAssembly. Is that the idea is that you have this thing, which weirdly it came out of browsers, and which are there was just this standard kind of happened by accident.
Mm-hmm.
So you can run WebAssembly in a browser. So but what if we took the browser runtime and we put that on a real computer and ran it in a data center? It's okay, cool, sure, why not? But the thing with that is that you can write something to run in WebAssembly and it compiles to this virtual computer. But the virtual computer is the same everywhere, which was the promise of the Java virtual machine. So you could write Java and have it run everywhere, which didn't quite happen. But with WebAssembly, you could write the code and have it run everywhere, but I can write it in whatever language I want. So I can write it in Rust or Python or Java if you want, and then that can run anywhere. But the problem we've got with containers is that it's basically statically compiling a program, except you have to statically compile the entire operating system and ship the whole huge thing everywhere. Some of these images are like a gig.
Yeah.
It takes forever, whereas WebAssembly is tiny.
Do you know what as well? I think there's, and we've perpetuated this ourselves, I think sometimes, there's a misconception that containers are portable. And I think by that, or we've come to that conclusion because they're smaller than virtual machines, so it's easier to copy them between machines and between registries and stuff.
Sure.
Yeah.
But they're not portable. Like if you create a container on
The
Linux
virtual
ARM,
machine is actually portable.
right?
Yeah,
Yeah,
But a container is not.
yes, yeah. So I think we're saying that WebAssembly will, we can write whatever language, compile it down to WebAssembly, and it's small and stuff like that. But that portability is something that we did not have with containers. Yet I think if you ask a lot of people, probably at KubeCon, they'll say, "Oh yeah, containers are portable."
Well, they're portable enough. And that seems to be like virtual machines was a reaction to physical hardware. It's like, well, we want to be able to run more than one operating system on one bit of hardware at a time, but we don't want to have a mainframe and use LPAS and Kix COBOL and stuff. But we want that. So that we're basically just reinventing the System 360 every like 10 to 15 years.
Of course.
Like, okay, fine.
Okay.
So,
11.
but the thing with WebAssembly, what it really needed was the component model, which has only just been standardized.
Yes.
And it's
well,
that happened like a month ago.
I would say that's open to change and flux going forward as well.
But then that's the key.
It is,
That's
yeah.
You're not actually writing full programs. Like some of it will be like write a database engine, but some of it will be like we'll write a secure sockets library.
Mm-hmm.
So instead of having to wrestle with the just Byzantine weirdness of OpenSSL, which is just fragile and horrific on the internal code basis, nonsense. But if we could
You could just run it in a container.
we could just run it in a container, and then
That's
we could
awesome.
have broken nonsense, but everywhere. Awesome. So what you could do then, because the component model has that standard interface, and that's the really important part, that composability. So I can say, well, I'm going to rewrite OpenSSL in something good like Rust, and now it's memory safe, and I can just swap it out, and none of the other program components need care. It's just seamlessly pulled out and plugged back in again. If that works, if we can make that happen, that will be revolutionary.
Yes. So just really quick on that, because I was at WASM Day yesterday, and towards the end of the day, there was a big slide up saying components are the new containers.
Yes.
Mm-hmm. And again, so I'm still not convinced we're quite there yet, but I agree that is the key. It's not just, yes, it's building on top of WebAssembly and all the goodness of smaller, faster, more portable, more secure, but the component model and doing components, when that starts to tick up, then I think we may have a revolution on our hands.
Well, because then not everybody has to write it. One person has to write it somewhere.
Okay.
And if I can get that component, like if I can have open source components, which are going to happen somewhere, I can just grab that and use it. So I don't have to write my full application stack. I can just grab bits and pieces and go, okay, well, I need some database, and I need some message queue, and I need the secure sockets columns thing, and I need some networks. Okay, I need a web server, and I just connect these things.
And you just focus on your business logic, as I guess people would say. Sorry, network.
No, as you're basically describing like modules or libraries in a programming language.
Exactly, it's dynamically linked libraries again.
Oh, yes, that makes everybody hurt a little bit. My issue with the component model is that what you've done is created an abstraction between two different components. And what do I know about abstractions? They leak.
Yes.
And if that abstraction is too leaky, then the component model falls down because you create dependencies between the components that shouldn't be there.
That's how Java failed. There's the leaky abstractions.
But I still don't think that you've answered my core question of what is the actual business need that's being solved by WebAssembly that is not solved by containers today.
So I'll take a hack at that, okay? So the edge and IoT, resource-constrained environments, containers. I know we're talking about containers sometimes being a gig in size and stuff. Of course, we can make them a lot smaller, but generally speaking, even a small container is too much to run at the edge in places like that. So as that becomes more of a thing, then WebAssembly is a much better fit there.
I don't know enough about WebAssembly to comment on that, but what is the size of the interpreter that runs the WebAssembly? And does that add the same amount of overhead that you would have if you just wrote a program that ran on a regular operating system on that IoT device? Because whether it's a container runtime or it's a WebAssembly runtime, there's a runtime that's adding overhead that might not be doable on a very small IoT device.
Gotcha. So I think even today in the WebAssembly space, the choice that you've got for runtimes is a lot more than you've got in the container space already. So there are dedicated runtimes that will run on these sort of funky architectures and stuff that you've got out there at the edge. And they're designed specifically for that, super small. Won't do everything that, maybe a more standard WASM time or WASM edge or something like that will do. Might not offer all of those bells and whistles. But it's a good question, and I think we'll get better at it going forward, but we're already at a point where, there are tons of WebAssembly runtimes out there for different use cases, targeted for different use cases.
The two big things that I keep hearing, AI and edge. And there's some intersection there as well. I can see the use case for edge, constrained devices. But the other big thing is AI. Does WebAssembly have a usefulness there? Because my understanding now is most of the model training happens on Kubernetes using containers that in part NVIDIA is supplying because they want everybody to use CUDA.
Yeah, yes, okay. Gen AI, I think, is vastly overhyped and the whole thing should probably collapse.
No.
It's just pointless. However, but I will I'll take the other side a little bit. There is a genuine use case in WebAssembly because they're small and fast. They spin up quicker, and a lot of the the AI workloads, but also just a lot of data processing workloads, which is actually vastly more interesting. So a lot of even backup systems are doing these data pipelines now, rather than just a boring copying. You just have stream processing of data as it flows through things. Mm-hmm. So for those, they're quite ephemeral little pieces because they're only processing state while it's live and then it goes away. So a little bit like serverless. But if you run that in a WebAssembly runtime, they're very, very small, so they have small memory footprint. You can fit a lot more of them into a VM or into a physical piece of hardware. And the spin-up time and shutdown time is really, really fast. I think it's about a tenth of what it would be for a Lambda. So your ability to run lots of those and have them be very reactive and very quick is really efficient when you're running these things at very large scale, like with Gen AI, or like these really, really massive data processing pipeline systems.
Can I just say, that's your other use case as well, though. Mm-hmm. The cold start times are so fast they don't feel like cold starts.
Yep.
10 milliseconds, if you sort of fine tune it as well, you can get into microseconds for startup times. And if you want to not be locked into Lambda or something like that, but you want an event-driven serverless solution, then WebAssembly is an absolutely, today, a stellar fit for something like that.
What I'll say, and this will be my last point, is if WebAssembly is looking for something to plug into AI, hardware is very, very difficult to get at the moment. So any way that you can get more work out of the hardware that you currently have, by bin packing better, by running it more efficiently, if WebAssembly has a role to play there to make AI model training and inference more efficient than containers, then I think that's a winner for me.
So at WASM Day yesterday, I think the second last talk at the end of the day, Michael Wan from WASM Edge did a demo where he was doing all about AI and stuff. I kind of had my phone on watching the Chelsea-Tottenham game at the same time. So I'll watch the replay, Michael, but there might be one for you to watch if you're interested in that space.
Excellent. All right.
Final word, Justin?
It has the potential to be really good. WebAssembly has the potential to be amazing. There are still a bunch of risks about how it could all go horribly wrong. So I am hopeful that it will succeed because I think, and I've written about this a couple of times over the last 18 months as I've been tracking the development, there's a whole bunch of different lessons from the last several decades of IT that I really hope we learn, and it looks like the teams involved in this have learned a lot of those lessons. So object request brokers and Corba, Java, the mistakes of Java, why do we use dynamically linked libraries instead of static ones, the issues with VMs and containers that we discussed, all of that needs to happen at the same time. That's really tricky, but it looks like they might pull it off. And if they do, it could genuinely be most important thing that has happened in IT for me for the last 20 years.
Whoa. All right.
And that's absolutely an incredible statement because, you know, the most important thing that happened in IT in the last 20 years was containers and Docker, right?
And
Or was it Kubernetes?
And Flash.
Or was it Flash? Or was it cloud? Or was there's been a lot of things. And frankly, I can't figure out my question about WebAssembly overall is I'm not sure yet that they have decided whether this is a dev or an ops technology. I'm not quite sure whether they're focusing on the right person that actually needs this solution and needs it now. And I think that ultimately that's and Nigel pointed this out earlier in the conversation, that what separates a successful solution from a not successful solution is if it's solving somebody's problem. And if that person actually wants the solution, if they want the solution. If that's what they want, then sure. But if it's not, then I think that it's going to be dead on arrival, or it's going to be a niche. And so either, we don't know. We don't know.
Can I say, just on that, maybe as my closing comment then, right now, like if you go to WASM Day at KubeCon, or if you go to WASM.io or WASMCon, the people there are the people that are building WebAssembly. And it's very much like I go in with an ops background to these events, and I sit there and I'm like, is everything good? And I'm like, okay, I've got maybe 2% of that, and by the time I go to bed tonight and wake up in the morning, I'll be 1%. It reminds me of the very, very early days of Docker and Kubernetes, where it's all the people that are building it. So right now, it's very much still pulling itself up by its bootstraps, if you will. It's so still a long way from getting to where you say, Stephen, it needs to. It's like, it's so nascent, but it's so exciting. And I'm going to try and trump Justin by saying not the best thing in 20 years, but the best thing in human history. No, I'm just kidding.
They're building it, but will anybody come?
Oh, well, if you build it.
Well, it's funny, Nigel, because that was actually, I attended the WASM presentations at KubeCon in Detroit.
Yeah.
And that was exactly my impression. I'm sitting there thinking, these people are not talking to me.
No.
But it's very cool.
Yeah.
Mm-hmm.
And I guess we'll see. So thank you very much for listening. I have to say, I was so excited to get these three people together on this conversation that I forgot to press record on the field recorder. But luckily, we have wonderful microphones on our cameras, so this episode will not sound quite as good as most on-premise IT podcasts. But Corey and the crew back home are going to do the best they can, and I really appreciate everybody listening. This is the On-Premise IT podcast. For show notes and more, go to gestaltit.com/podcast. Please look for us in your favorite podcast application and look for our other podcasts utilizing tech and the Gestalt IT Rundown. Thanks for listening, and we will see you next week.